So in the last video, we looked at functions that return functions, either by partial application or by using the explicit lambda notation. In this video, we're going to look at functions that take other functions as input. And this is a good way of making a function which does some specialized job into a function that does a more general job, and then using functions as arguments to specialize it down to a more specific example. So I'm going to introduce this by just taking this simple value definition here, 10, produced by adding 5 and 5, and showing how to generalize it and then specialize it back down to 10. So generalization, we can think of as a process of taking specific things, so there's 5 and 5 here, and just turning them into parameters so that we can write a function that does anything, or can add any two things together. So we could write a function called double that takes an x instead of the 5 and just adds x to x. So what I've done here is taken these two 5s and said, well, I don't care about it just being 5, I just want it to work for any value. So it's going to take an x and it can add x to x. And then we can test this by loading it into GHCI. And then we can write double 5 and we get back 10. And indeed, we can write a new version of 10, which is made by specializing double to 5. Now, we needn't stop here, so we could look at the definition of double and see that the other fixed thing is add. So this is referring to a fixed definition further up the file. So we can write a more general version of double, we call it apply copy. I'm going to write the definition out first before I write the type. So it's apply copy. Instead of having a fixed add, we take a variable f, which we're going to stand in for the possibility of add or something else, the variable x, and then we're going to write f, x, x. So this follows the same pattern as double. Instead of add, I've just got f. And now the type of apply copy is as follows. We've got apply copy with, and it's going to take its argument f. So if we look at the type of add, we'll see what shape this has to take. If we're going to specialize this with add, then one guess is that we can do int, error, int, error, int. So it's a function that takes two arguments, and then apply copy or return a function that takes one argument, int, and return an int. And then we can load that in. And now we can get back double by doing apply copy add 5, and we'll get 10. But we can go further. We can even supply functions which are anonymous. So rather than actually saying we're going to do add, so it's going to be a two-argument function, we can just supply an anonymous function here using the lambda notation. So this takes an x and a y and returns x times y, and this will multiply 5 by itself, so we'll get 25. And we can recover the add functionality by supplying the function which adds its two arguments, so you can get 10 like this. And indeed, these kind of short ones, where it's just one argument, we can actually do by just putting the name of the operator in brackets. So we can apply a binary function like this, which is an infix operator, just by writing its name in brackets. And then we can recover the original double as a definition just by partially applying apply copy to add. So we get double prime has the same behavior as double did before. Another example that we can generalize with is something like a quadruple function. So that's going to take an int to an int, and let's say it just works by doubling twice. So double x, where it takes an argument x. Let's make that nice. So what does quadruple do? Quadruple. It just multiplies its argument by 40 by repeated doubling. So now we can think, well, this is a sort of useful function, but maybe we just don't want to apply double twice. So we can write a generic function, and I'll write the definition out, that rather than applying some function to two copies of another input, it applies that function twice, once to the input and then once to the result of it. So that's following this exact pattern here, where we had double applied to x, and then we apply double to the result. And now we can actually ask the compiler what the type of twice is, and it will give us back this type, where it's not specialized to integers. We can just say it takes for any type t, it takes a function that takes t's to t's, and returns a function that takes t's to t's. And so I think it's always nicer to write this as a. So we can write this function as typed like this. And then to get back to quadruple itself, quadruple 2, we again specialize and write that quadruple is twice double. And let's test that. So quadrupling, this was the original function, and quadruple 2 indeed does the same thing. And we can work out that it does the same thing by a bit of unfolding a definition. So we can say quadruple 2 for any argument, x is going to be equal to twice double x, and then we expand out the definition of twice. So f is going to be double, x is going to be x, so this is going to be double x, and then that's the same as the definition of quadruple x up here. So we can see that quadruple 2 and quadruple are the same function by specialization. And indeed we can take any function that we can apply twice and use twice to do it. So we could do twice reverse hello, and of course this is going to be hello because it's going to reverse hello to ole, and then back again, so to get back to where we started. And we can also use it to iterate octuple. So we can just say this is twice quadruple, which is also the same thing as just saying that it was twice double. And then we load that in, we can find out that octuple indeed multiplies by 160. Multiplies by 16. So in summary, functions can take other functions as input. And this allows functions that capture generic patterns. So I've shown you some very simple examples in this video. And we can get from specific to general functions by replacing specific items of data in specific functions with variables, and then supplying those variables as arguments. And then we can specialize back from generic functions by supplying functions as parameters. So we saw how to do this in, for example, the twice function, where we specialized back to double by giving the add function. Specialized back to quadruple by giving the double function. And lambda notation is very useful for this specialization process, so that we don't have to name every function we're going to use. And we'll see many examples of this in the forthcoming lectures.